Hey Precalculus students, this is our second lesson on complex numbers in our Module 1. It's titled Lesson 5 in your binder, and this is the note sheet you're going to need for today. It has two sides, side with arithmetic, and then the back side with some summary notes, and you'll also need your binder open to Lesson 5 as over here. Nice. So we'll start with our do now. It said respond to the opening exercise on page S13. So on our binders, here's page S13. First page, lesson 5. It says write down 2 facts about I that you learned in our previous lesson. So if you've seen on the computer, if you remember from class, 2 important facts that came up were that I squared is equal to -1. That was that really important identity we used to simplify our complex powers. We used it to simplify, for example, I to the 6th by breaking it up into a bunch of I squareds and then plugging in our -1s as so. So we could use that identity to figure out our powers of I, and for example, that I to the 6 is equal to -1, and that all worked algebraically. The other thing we learned last time was that multiplying by I in the complex plane resulted in a 90-degree rotation. And that allowed us to solve powers of I geometrically. So I'm going to make a quick sketch here at the top. If I zoom in on this, we found that to find I to the 6, for example, we could start at 1, multiply by I. That means rotate 90 degrees, and that would take us to I. Multiply by I again, another 90 degrees takes us to -1, because that's I squared. Same identity as before. 90 degrees, that's 3 multiplies, 4 multiplies, 5 multiplies, and 6 multiplies. So multiplying 6 times took us right back to -1. So we could show geometrically and algebraically that I to the 6th is equal to -1. Nice. So that's a recap from last time. Today, we're going to be able to describe complex numbers, so we want to know what a complex number is and be able to represent them as points in the complex plane. We started that process last time. We're going to finalize it today. The second thing is we're going to be able to perform arithmetic. That is basically addition, subtraction, and 2 kinds of multiplication. Notice there's not division on here, not division. We'll cover that later in the year, this unit. So let's start by describing complex numbers. So this first thing we're going to talk about here is a Freyer diagram. It defines this concept, complex numbers, by having 4 pieces. It has a definition in our own words. And in class, we had some students mention complex numbers are, or I asked them like what complex means to them. They said it has more than one part. So these numbers might have more than one part. And then in particular, we also found that more than one part, they have a real part and an imaginary part. Cool. So here I'm going to give us some examples of complex numbers. So one example of a complex number would be 1 plus 2i. That's a simple complex number. It has a real part of 1, an imaginary part of 2i, and so together it's complex. That's more than one part. Another example of a complex number would be something like 1/2 plus square root of 3 over 2 times I. So this one looks a little bit different, but it still has the same basic form. It has 1/2, a real part, and it has square root of 3 over 2i, an imaginary part. Together as a complex number. A couple other examples. Let's say the number 4. So actually, mathematicians define complex numbers to be any number of the form, I'm going to write over here in our facts, of the form a plus bi. So a is the real part, b is how much of imaginary part we have. So the question is 4 a complex number? Let's see if we can write it in the form a plus bi. So if I write 4 that way, maybe it's something plus something times I. Well, the real part has to be 4, and then we don't want any imaginary part, so I can just write it as a 0i. So because we can write 4 in the form a plus bi, the real part plus some imaginary part, 4 is actually a complex number as well. So 4 would be a complex number. Maybe a final example would be like negative 2i. It's just imaginary. It's just the imaginary part of the complex number. But again, we could similarly write it as 0 minus 2i. So all that's to say that our complex numbers are really almost any kind of number, right? Complex numbers contain all the real numbers, the numbers we're familiar with. So negative numbers, irrational numbers, fractions, decimals, numbers like that. They also contain all of the imaginary numbers, which is all of those things with an I attached to it. So for non-examples, in this case, there actually are not. There are no numbers. Fix that. No numbers that are not complex. Or rather, there's no numbers that mathematicians have yet found that can't be written in the form a plus bi. All right. So the next step, that's how we can describe complex numbers. So we've seen some examples. Go ahead and take a couple seconds and go to your binder and take a couple seconds and look at this visualizing complex numbers. So we described them, we described the concept. Now we're going to talk about how we can visualize them. So first of all, I want to point out that this axis looks a lot like the coordinate plane that we're used to. Normally we have x's and y's, but this time we're going to have our real axis. We talked about this in our last video. That has all our real numbers like 1 and 2 and 3 and 4 and a half. And we also have our imaginary axis. And together they form this complex plane where we're going to visualize our numbers. So for example, say we're asked to plot the complex number 5 plus 2i. If I'm going to go plot that, it has a real part of 5. So I'm going to highlight that in yellow. Real part of 5. I'm going to go over to 5 on my real axis, and it has an imaginary part of 2i. Oops, different color. 2i. So on my imaginary axis, I'm going to go up to 2i. So I went over 5 to the real part, up to 2i in the imaginary part, and I plot that point, plot it in green. That point is the number 5 plus 2i. So plotting complex numbers is really just going to our real part on the real axis and going to our imaginary part on the imaginary axis. We can plot these all over now. So let's say we want to plot negative 3 plus 2i. So similarly, now we have a negative real part, so I'm going to go over negative 1, negative 2, negative 3, and then up to 2i, 1 up 2i. So that would be negative 3 plus 2i. We could also plot, say we wanted to have one with like a decimal in it. We could say plot negative 2.5 minus 3.5i. So I'm going to go to my real axis first. Real part is negative 2.5. So start at 0, negative 1, negative 2.5, right about there. And then I'm going to go down 3.5 on my imaginary axis. Down 1, down 2, down 3.5. So maybe we're right about there. And I'm just making those marks along the way to kind of help me sketch out my path. But once we're done, we just have to plot this point, negative 2.5 minus 3.5i. So plotting numbers on the complex plane is pretty straightforward. It looks a lot like plotting x and y values. In class, people mentioned it reminded them quite a bit of slope as they go over and up, things like that. So that is our first objective pretty much summarized. Describe complex numbers. We have our Freyer diagram here to help us understand the concept of complex numbers. And then we know how to represent them as points in the complex plane using what we described over here. So in the next section, We're going to talk about how to start doing this complex arithmetic, and then we will do some practice.